So in this video we're going to have a look at how we can calculate exactly the length of the lever we'll need to generate the 700 Newton output force we're wanting. So I'll start just by noting down the forces we know again. Big F, input force 150 newtons. Input distance is now the unknown, we're going to work that out. The output force we'll put in, we know we want 700 newtons. And the output distance will keep the same from our model because we're not going to change that, we're just going to change the input distance, that lever length. So we can use our FD calculation, so big F times big D equals little f times little d. 150 times D equals 700 times 80. 150D equals, get out the calculator, 700 times 80, 56,000. So D by itself is going to be 56,000 divided by 150. .373 millimeters. So that's the arc length. So if we have a look back on the that original sketch we did from the CAD, our first line that we drew with the compasses 355. So this new arc's 373. It's going to be a little bit bigger, not much. Two ways you can do it. One is kind of trial and error, just and a little bit to the lever length, run through the calculations until you get an arc that's at least 373 or bigger. The better way would be to kind of reverse engineer these calculations and to work it out. So on the right hand side is the calculation that we did originally to work out how big that input distance was, how we got 355. Essentially we're just doing that in reverse to work out what the diameter is, therefore what the radius is, and what the length of our lever is from that. So 373 millimeters is a portion of that circumference, isn't it? So it's just from here round on the diagram, and we know from the earlier calculation that actually in our model it's 1 over 2.83, so 2.83 of that distance makes the whole circumference. So we'll start by doing 373 times 2.83. If you're not quite sure how we got that number, watch that first video on how to find the length of the input distance, and it'll talk through how to work that out. But for now, 373 times 2.83 equals 1055, and that's the circumference of the whole circle, so that equals C. And then we can now kind of reverse engineer that calculation. C equals pi d, because C equals pi times not input distance but diameter, C equals pi times the diameter. We know the circumference is 1055 equals pi times the diameter. Diameter then equals 1055 divided by pi. Diameter equals 1055 divided by pi. 335.8, so we'll call it 336. Now if that's the diameter of the whole circle, in our Can Crusher the lever just represents the radius of that circle. so it kind of pivots round, doesn't it? And we just want to find the radius. The radius is half of the diameter, so our radius equals diameter divided by 2. Radius equals 336 divided by 2. Radius equals, in this example, 168. Now, if you have been watching all of these, you'll know the first diagram we did, just the card model, the lever length was 160 millimeters, so it only needs to be just 8 mil more, and we'll generate 700 newtons output force. So that there is working the calculations in reverse to find our lever length. The radius of the circle, 168 millimeters. That is how long our lever needs to be.